Hi, welcome to lesson 19b, the area between two functions. The goal of today's lesson is to calculate the area between two functions. So we've been looking at areas under curves before, and we've noticed that when we find the area under a curve, suppose a curve is like this, we're looking between A and B. So I'm sure you've seen this diagram many times before. So we're finding the area under the curve, and basically what we're actually doing is we're finding the area under this curve but above the x-axis, where the x-axis, the equation is actually y equals 0. So what we've been doing is we've been finding the area between two curves, but the two curves are the function that's given and y equals 0. Okay, so but that's been we've been calculating that by finding the antiderivative of f of x with respect to x. And then when we evaluate that, that is uppercase f of b minus uppercase f of a. So that's all fine and good, and that's absolutely correct. But what we're actually doing when we're finding the area, when it's in this form, we're actually finding the area between two curves where the curves are f of x minus 0. So we're actually subtracting the two functions. One function is f of x, the other function is y equals 0, which is the x-axis. Okay, so that's how we've been doing it without actually mentioning this minus 0, because it's just 0 anyways. So this is actually how we've been calculating the area under the curve when f of x is above the x-axis. And if the function is below the x-axis, we've been doing this without actually writing it all out. Okay, so we realize that area under the curve is a negative value because it's below the x-axis. So this gives us a positive value, this gives us a negative value, but then we'd have to take the absolute value of this to find the actual area under the curve if it's below the x-axis, because we know the areas have to be positive. So now what we're going to do is, if the function is a little bit more complicated than just y equals 0, then what we're going to do is we're still going to do the same thing here. We're still going to subtract the functions, but whatever function's on top, we're going to just subtract that as we have been doing. So we're going to be finding the upper graph or upper function minus the lower function. Okay, same sort of idea. We're going to have the two functions, we're going to subtract them, and then we're going to evaluate that difference with respect to x. If we were to do this in function notation, then that area between two functions would be f of x minus g of x, where f of x is the upper function and g of x is the lower function. Okay, so let's take a look at an example to see how this works. Okay. Moving right along, let's say, for example, that we want to find the area between function f of x, which is negative x squared plus 4x plus 4, and function g of x, which is the function 2x plus 2, between x equals 0 and 2. Okay, so by looking at this, I see that that's a quadratic, which is opening down, and the y-intercept is 4. Here this is a linear function where the y-intercept is 2. So I believe that this function is going to be above this function and opening downwards. So it looks something like that. And so we're going to find the area here between 0 and x equals 2. Okay, so that's basically what we're going to try to find here. So we want the area between the two curves, between 0 and 2, and so it's going to be f of x minus g of x with respect to x. And we substitute in the functions, so we get negative x squared plus 4x plus 4 minus, I'll put brackets around this one, 2x plus 2 with respect to x. And then I'll simplify inside here, so I get negative x squared, 4x minus 2x is going to give me 2x, and then 4 minus 2 is going to give me 2. And then I just go ahead and take the antiderivative, so I'm going to have negative 1/3 x cubed plus x squared plus 2x evaluated from 0 to 2, and then just substitute into the values. So you get 1/3, negative 1/3, 2 cubed plus 2 squared plus 2 times 2. Now because all of these have x's in them, all of that's just going to go to 0. I could write it all out and substitute the 0 in for each of those, but it's all going to disappear anyways, so I don't really need to. I guess just for being complete, I will do that just to show you that it all just disappears. And so then I just work this out. 2 cubed is 8, 2 squared is 4, plus 4. So I'm going to have negative 8/3 plus 8, and that's negative 8/3 plus 24/3, which gives me 16/3 units squared. Okay, so that is the area between those two functions between 0 and 2. So tomorrow we're going to look at a few more examples in class, and in the meantime could you please look at the examples in your textbook and then take a quick glance at some of the questions that I'll be asking for you to practice on after the examples tomorrow in class, and you'll be all set and ready to go. So thanks for watching, and we'll see you in class.